Hello everyone, today in this video we'll be discussing the first module of operating system, which is the introduction to operating system and a few concepts related to it. So we'll be going through each topic very quickly, and make sure you watch the video till the end, and if you like the video hit the like button and don't forget to subscribe to my channel. Okay, so let's begin. What's an operating system? It's a interface between the hardware and the software. Okay, that's known as operating system, and it provides an environment for the execution of programs. Now there are four components of a computer system, of which the operating system is a part. Okay, the other three are hardware, application programs which you have installed inside the computer, and the users. Okay, these comprises of the computer system. Then the coming to the views of OS, that means there are two types. First one is user view. Users are of different types, like standalone systems. It's mainly designed for the ease of use and high performance, like a single user using the system. For him, the ease of use and high performance is important. Like that, for the different terminals where the users are present in different terminals, that time maximum resource utilization is more important. So the operating system is designed that way. Maximize resource utilization means the resources which are available, like the secondary memory storage and all, those accession should be faster. Coming to workstations, workstation means those which are acting as the servers in the different parts of the place. Those should have the ease of use and resource availability, since the files are accessed very frequently from workstations. Then the fourth one is handheld. Handheld means the mobile phones which we use. What do we expect from the mobile phones is ease of use and good performance. Then the last one is embedded systems. That means the systems which show the status of the work by LEDs. Okay, it means a small LED will be there. If it's green means it's working. If it's red means it's stopped. Those things. Okay, that's known as embedded systems, and the LEDs are nothing but the status shown by the work. Okay. Coming to systems view, there are two things. First one is resource allocator, means the operating system should provide an environment for the management of the files, and control program means it should manage the instructions and the control executions of the program. Okay. How is the system organized? There are many devices connected to the memory via bus. Okay, so this is the organization of a computer, and Bootstrap program is the first program. When we open the computer system, at that time some code gets run, right, and in the black screen, that's known as Bootstrap program. It initializes all the hardware and the configuration files. We'll see about Bootstrap program in the upcoming topics. Then interrupt handling. Interrupt handling means whenever a program is being executed, at that time the input or the output is needed by the user, or some other task which requires some waiting. Okay, that's known as interrupt. And there are some few steps which are followed in the interrupt. First one is when the interrupt comes to the processor, it looks at the vector table, means the vector table has which interrupt has what to be executed. Okay, suppose that if the interrupt is to take the input, at that time the vector table will have the address of those memory programs which will take the input. Okay, so after looking at the address, it will execute the instruction to take the inputs. Okay, and after the taking of the inputs, it will resume the normal execution of the program. The next one is storage structure. See, programs are stored in the main memory, and the data is stored in the secondary storage. Okay, this is a very large data, and the programs which are needed for the execution of the system are stored in the main memory. Main memory is shorter than secondary storage, and the hierarchy which you should remember is this is the smallest memory, and it's the most fastest and the costliest. Okay, this is the largest memory in the computer system, and it has the permanent storage of the data, because when you shut down the laptop or the computer system, the data doesn't get lost, whereas in registers and cache it gets erased. Okay, but this is the for used for faster accession, and this is for the permanent storage of the data. The next one is input output structure. See, whenever we give an input, what we do is we are giving the input to a device controller. What does a device controller do? It will store all the inputs, and when the CPU is free, at that time it will process the output. Okay, and it will be stored in a queue. Similarly, is for the output, when the processor sends the data to be output, it will be stored in the device controller, and when the device is able to output, it will output the data present in the last queue. Okay, this technique holds good for smaller data. In case the larger data is there, then we can't use device controller. It will take a lot of time. So what we'll do is we'll use the direct memory access. Okay, direct memory access, the device has the direct connection with the instructions and the data, which is stored in the main and secondary memory. So the device action will be faster because the data is large to be processed. Okay, So this is all about the IO structure. Coming to the next one, which is computer system architecture. There are three types. First one is single process system. Okay, in single process system, single processor will be present which will be carrying out the task. Okay, so suppose that if five tasks are there, each task will be executed one by one. Okay, whereas in multi-process system there are multiple processes and each of the job will be taking place simultaneously. Okay, parallelly. So that's known as multi-process system, and there are two types of it. First one is asymmetric. In asymmetric, the processor will have the master-slave relationship. That means a processor will be a master which will monitoring all other process, whereas in symmetric there is no master slave, it's peer to peer relationship. Okay, that means each of the processor will be monitoring each other. Okay, then third one is clustered systems. In clustered systems they will be connected through a network, and they will be sharing the same storage space here. Okay, the storage space will be same and they will be connected with each other for by the network for sharing of the messages among each other. Okay, coming to operating system structure, there are various types of structures. First one is multi-programming. In multi-programming, there are if this is the CPU, in CPU will provide with all the jobs that the CPU has to do, and it will execute each task one by one. Okay, suppose that while executing this task, there comes a instruction for input output operation. At that time, CPU has to wait for the input output, right? At that time, CPU will not wait. In multi-programming, what it will do is it will execute the second job at the same time while the input is coming. Okay, so it will save the time and it maximize the CPU utilization. Okay, the next one is time sharing. Time sharing is a similar concept, but in that multiple users will be there. CPU has to give for each user a fixed amount of time, and that will be changing for each user. Okay, means if it's 1 second, it will be giving 1 second to this user, and then next second will be given to this user. Like that till end, it will go and it will repeat from here. Okay, so it will be like the interactive program because it will be very short duration of time, and each process will be executing in parallel. Okay, it will be looking like that. So that's known as time sharing. The next one is multi-process system. In these systems, the process will be multiple and all the tasks will be carried out simultaneously. The last one is distributed systems. In distributed systems, what the thing is, there will be many computers and it will be connected by a network. Okay, and they will be sharing all the resources with each other. Note here that all these systems look very very similar to each other, but there are some technical differences. Okay. Coming to the next topic, operating system operations, we have dual mode operation. Okay, in dual mode operation, we have user mode and kernel mode. So let's see what's a user mode and a kernel mode. Suppose the execution is going on here, and at a point of time, kernel mode is on. Why? At what time the kernel mode is called? See here. Suppose that there's a program to take the input of two numbers. Okay, so at that time, the user processor will be displaying the numbers which are to be displayed and the addition of the two numbers. But at the time when the input of the two numbers comes, at that time the mode changes from the user mode to the kernel mode, because kernel mode is able to interact with the hardware to take the input from the user. Okay, so after the taking of the input from the user, when it's over, it will return from the kernel call and it will execute the user process. Okay, so that's known as the dual mode operation. Whenever a user is using a CPU for a longer time, at that time the timer is used. That timer means it will CPU will take the control of the system in specific periods of time. Okay, to not let user use the computer for a longer amount of time. Okay, that's known as timer. Whenever a program is getting executed, at that time there are many resources required by the program like the CPU and the memory, storage memory, and the files. So those management of the process are carried out by the process management. Coming to memory management, there are a lot of files stored in the memory. To organize those files which are similar and which are not similar, and to organize those files in different groups, that process is carried out by the operating system. Okay, that's known as memory management. Coming to storage management, there are three types. First one is file management. So the operating system should be able to create, delete, organize, and manipulate the files. Also, it should be able to map the files onto the secondary storage. So you know that the secondary storage is a large storage, and to get the file from it is a larger process. So what we use is the cache. What will cache do? It will store the recently accessed files, and it will be sent to the processor. So this management is carried out by the operating system. Coming to mass storage management, if there are duplicate files in the secondary storage which will take up a large space, those will be clearing of those files, free space management, and the organization of the memory inside the secondary storage is carried out by the operating system. And the last one is caching. Caching means the same thing which I have told. The between the secondary storage and the processor lies the cache. Okay, it will have the recently accessed files and it will be sent to the processor to save the accession time, because from secondary storage, if you want to access any file, it will take a large amount of time. Okay, so cache is used for saving time. Coming to protection and security, the main things which you need to know is, see here, there are many processes going on simultaneously. Okay, like displaying the time and taking the inputs, and the other processes which are carried out by the CPU. So what happens is, sometimes this process need the execution of the other process. Like for example, if you have to store a file, okay, a text file is there, if you have to store the file in the memory, at that time the process related to the memory are accessed by the CPU for storing this file. So it's very important that the process which are accessing the data should be authorized. Okay, so all not all the process can access the data, only a few process can access the data. In case all the process are allowed to access the data, any external user can access the data which are present in the memory. So that's not safe, right? So to avoid that, what we can use is um, user IDs. Okay, so by using the user ID, what we can do is we can restrict the unauthorized access of the data. Okay, so special purpose systems, there are three types. First one is real embedded system. So what's a real embedded system? In this, we'll be getting the output based on the inputs in the real time. Okay, so we'll be using sensors also. So by using a sensor, we can in home set the temperature before coming to the home. Okay, so that's an application of real time embedded system. Next one is multimedia systems. So these type of systems handles the multimedia files like videos and audios, and handheld systems are the systems which are present in tablets and mobile phones. Environments, there are four types. First one is traditional computing. It's nothing but the normal computing which we see in the companies, where are many computers will be there and they will be connected through a single CPU, which will be using the concept of time sharing. The next one is client server computing. In this, the clients will be connected through a network to a single server. Okay, so this server will be responding to the needs of the clients. The next one is peer-to-peer computing. In this, there will be no client or server, but suppose that this computer is providing the data, it becomes the server, and the computer receiving the data becomes the client. Okay. The last one is web-based computing. Those are the computing devices which are connected through a network in the different parts of the world. Okay. To operating system services, there are two types of services. First is for the users, and second is for the system. For the users, consider this program here. The users can execute this program, and it should be first loaded from the memory, and the transferring of the data means IO operations are also carried out, and file is to be stored inside the secondary storage, that is carried out by the operating system. And if this is to be transferred to the other parts of the world, like by using a network, that's done, and the error detection is also done by the operating system. For the system, there are three operations. First one is resource allocation, that means memory management, and whenever we input something, that should be updated in the memory, right? That's carried out by the operating system, and the protection and the security of the data is done by the operating system. User operating system interface means when there is a system here, and how will the user access the operating system. Okay, there are two ways. First one is command line interface. See, either the user can write the commands in the CMD, that what the thing is to be carried out, like creation of file, deletion of file, or taking an input, and so on. So that's one way. Another way is to have the icons in the computer system and click on the icon. Okay, so for each icon there will be associated tasks which will be executed based on the programs in the memory. Okay, that's known as graphical user interface. Whenever a program is getting executed, at that time, if the program requires the um, functions of the operating system to be carried out, at that time system call is made. Okay, so there are three types, three general methods of passing parameters. First one is registers. Means whenever a process is there, and the parameters means the input and the output values are there, those are to be passed to the operating system. The first way is to use a register. Okay, to pass the values in the register, and the register will transfer those values into the operating system. The second is the address of the parameters. In this case, if the parameters are in large number, at that time what we will do is we will store the parameters in a block, and we'll send the address of the block to the operating system. The third is a stack. By using push and pop operations also, we can access the operating system. Okay, there are total 6 types of system calls. Let's look one by one. First one is process control. In process control, either we have to end a program, or load a program, execute a program, and terminate the process. Like such events and are carried out by the process control. Okay, for those carrying out those events, we are using the process control system call. Okay, the next one is file management. In file management, we will include the operations to include the system calls if we need to create, delete, open, close, or read or write operations. Okay, the those are made by the file management call. The third one is the device management. In case multiple users are there and they need to access a particular device, at that time we have to manage the device, and by using a system call we will be taking the hold of the device and releasing the device when we further no more require it. Okay, so that's carried out by the device call. Okay, fourth one is the information management. In information management, if you have to access the time data in the system data or the processor of the system, at that time we will be calling the information call. And communication call means if you have to send the data to the other devices, remote devices, by using a network, at that time we'll be using a communication call. The last one is the protection. If there is an user trying to access the system resources, we'll be doing a protection call. By using a protection call, we can authenticate if the user is allowed to access or not. Okay, operating system just provides an environment for the execution of programs, but there are many other things, like we have to take the input, display many things, save the data. Those things are carried out by the system programs. There are total 6 types. First one is file management, which handles all the file data, and the second one is status information, means what's going on with the programs. Those things will be given by the status information. Then to modify the file content, file modification is used. And in programming language support, the compilers and the debuggers which we use should support a large variety of languages. And to load the program and execute the program, loaders are used. And to communicate between the other users present in different parts of the world, the communications are used. There are system programs which provide the ease of communication. Okay, topic we'll be looking at the things to keep in mind before designing an operating system. Okay, so firstly, the design goals are different for the user and the developer. For the user, the design goal will be it should be easy to use, user friendly, and easy to learn. Those are the user requirements. The system requirements are that it should be easy to maintain, and it should be reliable, and it should be easy to make changes in it, and those things will be coming under system requirements. Okay, after getting to know the design, we have to see the mechanism and the policies. That means policies say what is to be done, means if the implementation of the operating system is there, what the operating system should include, and mechanism says that how to include the particular feature. Okay, and implementation means the implementation of the operating system in assembly level language or high level language. Let's look about the operating system structure. There are 4 types. First one is simple structure. In simple structure, it was used in olden days. In that, the application programs by the user were directly written into the hardware. Okay, means disk. So it's very unsafe also, and it's very less organized. So to overcome this, in Unix software, the later updates came where the kernel was included. Kernel is in between the user and the hardware. So what happens is, if the user wants to write some data into the hardware, first the system call should be made. System call will look if the user is authenticated to write the data. At that time, the data will be written, and there will be terminal, device, and memory controllers which will control the writing of the data by the user. Okay, so in this way it's much more organized and safe. Okay, the second one is the layered approach. In layered approach, a large amount of code is divided into many layers, so that the core layer is the hardware and the top layer is the user interface. So whenever user wants to access the core data, at that time it will pass through many layers, and each layer will be the part of the data and the routines needed. Okay, so in this way it's much more organized to handle any errors which happens. We'll be knowing exactly in which layer it has happened, so it will be easy to debug the error also. Okay, the third one is the microkernels. In microkernels, the processor is designed to be of the smallest size, and additions to be made can be added by using the extensions present here. Like the extensions can be increasing the memory or the process speed. Okay. And the fourth one is the modules. In modules, the whole task will be divided into smaller parts, and whenever a part is required, at that time the kernel will be connected with that particular part. And kernel has no other function other than load and communicate. Okay, talk about virtual machines. This is the diagram for non-virtual machine, And this is the diagram for virtual machine. In each machine we will have three parts: process, kernel and the hardware. The difference lies here. In a virtual machine, the process will be divided into many parts, so each one will be executing independently, okay? But the hardware will be shared among all these processes, okay? So it will look like all these processes are being executed in different computers, whereas it's the same computer, just the kernel is divided and distributed into many parts which are used by different processes, okay? Building an operating system, many factors are to be kept in mind. For example, the operating system which we designed may not work in a particular environment. At that time, we have to include the hardware configuration to configure the specific needs of the environment. We can make the use of operating system in that environment. Okay, so the configuration should be included. There is another part of variable hardware configuration which is much more modifiable than the specific hardware. Some users require to change the source code, which is the software. So OS source code modifiable should be included, and configuration table means the parts of the system which have to be changed. And in the configuration table, we will be having the information regarding what should be changed to make the changes which you need. Okay, and some of the operating systems also have the feature to rebuild the entire application, means you can change the whole kernel, okay? So that information will also be present in the manual. And the system boot means whenever you have made any change to the hardware or the software, to apply those changes you have to restart the computer. That's known as system boot. Understand what actually happens in a system boot. When we on the system, it runs the bootstrap program. What's a bootstrap program? Bootstrap program is nothing but it checks the hardware and the software of the computer if it's working properly or not, okay, before owning the computer. And the programs which are needed to execute the operating system are loaded in the kernel, and then the kernel authenticates the user whether the user is authorized to access or not. If the user is authorized to access, at that time the system will be on and the system can be used, okay. Topic will be going in detail regarding the process, okay. So let's first understand what's a process. Suppose that this is the program here. The program is a static data, which means the process will make the program execute, okay. So what's the process concept? Process concept means where all the process things which are required by the process are stored, okay. So the memory will be organized in this form. We'll be having the stack at the top, which means which will store the local variables and the return address, and the heap will be having the dynamic memory allocation, and the global and the static variables are stored at different part in the data, and in the text part you will have the program, okay. And the process will be using all of these data one by one when it's needed, okay. So the middle part where you can see here is can be used by the stack or the heap, okay. Now let's see what are the steps in which the process works. Firstly, a new process will be in the processor, and once it's ready to be executed, it will be in the ready state, and then it will be dispatched to running state. Okay. And if the process is over successfully, it will be in the terminated state. And if the process has to wait for some information, it will be in the waiting state. Okay. So these are the states of the process. Control block is a type of data structure which will have the following information about the process, like the process state, program counter, and the CPU information, and the input output status, and the other informations, okay. So by using this block, the processor can easily access the required data. Suppose that this is the CPU, and in the CPU we'll be providing with many jobs, okay. So for each job it will be stored in the job queue, okay. And whenever a job is ready to be executed, it will be transferred to the ready queue, okay. So in ready queue, all the jobs which the CPU must execute at the moment will be present here. And whenever our job is getting executed, but at that time it requires an input output operation, at that time CPU has to wait. So at that time the job will be present inside the device queue, okay. Here it will be the waiting time for the job. After the output operation is executed, it will move to the ready queue, okay. Here the execution will happen, the normal execution will resume, okay. Scheduler is a software which selects which program the CPU should execute by considering many factors like the time available for the CPU and the resources available for the CPU, okay. By considering those factors, the job is selected. And there are three types of jobs. First one is the job in the long-term scheduler. In this type of job, the job is selected from the secondary memory, so it's a large task and it requires a lot amount of time. So if the CPU has a large amount of time, and the resources available, it can use the long term scheduler job. The second one is short term scheduler. In this case, the resources available are very less and the time is also very less. Okay, at that time, short task can be executed by using short term scheduler. The third one is medium scheduler. In medium term scheduler, the job is not very large as the long term scheduler, but not very short also like short term scheduler. It lies between. Okay, at that time, the medium term scheduler is used, which is very similar to the function calls. Suppose that we are running a main program, in that we have to add two numbers. Okay, so there is a function defined in the memory to add two numbers. At that time, what we'll do, we'll call the function. At that time, the function will execute the adding of two numbers, and the sum will be returned to the main program. That's what happens here also. In this, the process will call the process 2, which needs to be executed by using a PCB. What does PCB do? It will handle the system call and the return calls. Okay, operation on the process. Okay, so there are two operations. First one is creation, second one is termination. In creation, if a process is to be divided into two parts, it will be divided in this way. Okay, and those processes can also be divided into further parts. Okay, so this is known as process creation. And process termination means this main process of which the process was divided, it can close any of these processes seen here. Okay, that's known as process termination. In a computer program, there will be many processes going on simultaneously. So the communication between each of these processes is nothing but the interprocess communication. There are two types. First one is independent process and second one is cooperating process. In independent process, there are those processes that cannot be affected by other process. Okay, so in cooperating process, we have the process which have the communication between each other, and the process can affect the other process. Okay, so there are two types of cooperating process. First one is shared memory and second one is message passing. Let's see the difference between each of these. In shared memory, the process will have the same data structure. So the process will be accessing the same storage, and they can read and write in the same location. In message passing, there will be different data storage for each of the process. Okay, so if they have to share some information, they have to use the system call to exchange the information. And the second difference is that it's used for sending large block of data. Okay, because in shared memory you can access the whole memory, you can access the whole storage, so the large storage can be accessed, whereas in message passing large data cannot be sent. Okay, so it's for small data. In shared memory, system call is not needed because the storage is being shared by two processes, and in the message passing, system call is needed, and the message is sent faster because there is no need of system calls, and the message is communicated slowly because of the system call delays. Okay, message passing, first one is naming. There are two types, the direct and the indirect. In naming, you will have the name of the sender or the receiver, and you will have the send or receive here. Okay, in indirect, you will have to send the message to the inbox, and the inbox will be checked by the receiver and the message will be taken. Okay, second one is synchronization. In synchronization, there are two types. First one is block. In block, the message which is received in the waiting time, when the sender is ready to send the message, it will be taken. And the second one is non-blocking. In non-blocking, the receiver will send the message and not wait for the sender to send, but it will carry out the other task. And the third one is buffering. See, whenever we do an input to the system or the output, at that time the input and the output are stored in the buffer queue. In that, all the system, all the variables and the input output operations are stored, and that will be given to the program. Same is in the other way also. The program will send the data to be outputted, that will be stored in the buffer queue, and after the time when the input output operation is free, the data will be output. Okay,